don't have a worksheet for Chapter 5, Section 1. It's such a simple section that I'm going to work right from a few problems that I have. So first of all, I just want you to know that Chapter 5 is titled Systems of Linear Equations. And so let me just describe to you a linear equation. A linear equation is one where the variables, in this case x and y, are raised to the first power. And if I were to graph these would form a straight line. When I have a system of linear equations, that just means that if I have two variables, then I would have two equations. And this would be called a system of equations. If I graphed this one, and I'm so making this up, if I graphed this one, it looks to me like the y-intercept would be about right here, and the slope would be a -2/3. So this line would look something like this if I graphed this one. This line right here, I'm going to do in red, if I were to graph it, it would intercept the y-axis way up here, and it has a positive slope. It would look something like this. So we're going to graph a system of equations, and we're going to find where those two lines cross one another, and that ordered pair, that x and y value, are going to be a solution for x and y in both of these equations, again, which is called a system. There are all kinds of applications of this. The first question that I'd like to do here is to take the statement 5x plus 2y equals 1 and just check a couple of ordered pairs and see if they work in that equation. So this is not a system, this is just an equation, and I'm just doing some checking. So I'm going to take 5, and for x I'm going to substitute in 0.2, and then 2 times y. For y I'm going to substitute in a -1, and I'm going to just see if this checks. So 5 times 0.2 is equal to a +1, and then 2 times a -1 is equal to a -2. And I want to know, I want to know if that equals a +1. Well, on the left side I have a -1 equals a +1? No, not at all. So this ordered pair does not check in this equation. I'm going to do it again. I'm hoping that I have an ordered pair that's going to work in this equation. How about if we try x is 1 and y is a -2. And let's plug a 1 in for x, so 5 times 1. And then for y, let's plug in a -2. And let's see if that checks in this equation. So here we have a 5 plus a -4. Does that equal 1? Yeah, it does. And so this ordered pair, yes, it does work in this equation. So one of the things we have to be able to do in Chapter 5 is we've got to be able to substitute an ordered pair in and see if it works. Here's the next thing that I'd like to be able to do. Let's say I have an equation, 6y minus 5x equals 60, and I give you a value for x. Let's let x equal -10. I want you to find for me a value for y. So if you put in right here for x a -10, so you have a -5 times that -10, bring down my 6y, and then we just follow the process of solving for y. So this -5 times a -10 is a +50, and then I want to subtract 50 from both sides because I want to get the y term alone. So I have 6y equals 10. And finally, I'm going to divide both sides by 6, and I find out that y equals, let's see, that's going to simplify to 5/3. So when x is equal to a -10 here, I have just shown myself that y would equal 5/3. So please be ready to do that as well. Let's do this very same equation one more time. So 6y minus 5x equals 60. And this time I want to try x equals 8. Now the reason I'm doing this is I want you to see that there's oodles of numbers you could put in for x. So far I think I've put in a -10 and now I'm putting in a +8. It's unlimited. There's an infinite number of values I could put in here. So in other words, there's an infinite number of ordered pairs that will work in this equation. So now I'm going to add 40 to both sides, and I'll have 6y equals 100. And when I divide both sides by 6, I have, let's see, they're both even, so 50, 2 goes into 100 50 times, 2 goes into 6 3 times. So when x is 8, y is 50 over 3, or yes, you could call that, I think it goes in, 3 goes into there 16 times, that's 48, with 2 left over. So the ordered pair 8 and 16 2/3 works in this equation. Next, say I had a system of equations. So 2x plus y equals 8, and then 3x minus y equals a -13. And I want to know if x can be a -1 and y can be 10, or in other words, does this ordered pair check? Does it check in the system? And so if it checks in the system, it's got to check in both equations. So I've got to try it in both. So let's go ahead here. So 2 times x, which is a -1, plus y, which is 10. I want to know if that equals 8. And sure enough, it does. But that's not good enough. I have to show that it works in the other equation as well. So 3 times x, which is a -1, minus y, which is 10. And I want to know if that equals a -13. So I have a -3 minus 10 equals a -13, and that checks. So yes, that ordered pair checks in the system. And if I were to have graphed it, the two lines, the ordered pair works. The two lines, and I'm really just kind of taking a, let's go here. X is a -1, y is 10, way up here. Maybe I'll, so right up here. So those two lines might look something like this. They might intersect right there, where x is a -1 and y is 10, when we get ready to graph those. Okay, let's do another one, because I'm pretty sure the next one that I picked does not work. So I'd like to use 6x1 plus x sub 2. I'm just wanting to use subscripts to get you used to that, equals 5. 3x1 minus 4x sub 2. And I want to know if that equals a -1. And then I want you to try x sub 1 equals 1 and x sub 2 equals a -1 in both of these equations. So take a minute, hit pause, and see if they work. I'm going to go ahead. I think I'm going to do this one up above. So I'm going to take 6 times 1, because x sub 1 is 1, plus a -1 for x sub 2. And I'm wondering if that's equal to 5. So is 6 plus a -1 equal to 5? Yes, it is. Let's go down here. So 3 times x sub 1, which is 1, minus 4 times a -1, because x sub 2 is a -1. And so does 3 plus 4 equal a -1? No. So this ordered pair does not check in this system of equations. So what's going to happen is we're going to solve systems of equations, and what you're going to do is every time you're going to check your answers, and that way you know you can get 100%, because you solve and then you put your answers for x and y, or x sub 1 and x sub 2, into the original system, and if you get to say yes to both, then you know you are correct. Here's my last problem. I've got a story problem, and it says that a student invested a total of $2,000 in account X and account Y. In account X, the student was making 4%. and in account Y, the student was making 5%, which is killer good interest. And it says that the interest as a result would have been $92. So what I want you to do is I want you to check and see if the student invested $1,200 in the account called X and $800 in the account called Y. Does this check in the system? Well, it's pretty easy in this one to see that 1,200 plus 800 is 2,000. So I can say yes, it checks in this one without writing anything down. In this one, I got to get my calculator out and take 0.04 times 1,200 and then take 0.05 times 800 and see if that equals $92 worth of interest. So how far can I move this? So let's go 0.04 times 1,200. And then I'm just going to go plus 0.05 times 800. I'm going to hit enter and move my calculator over. So 0.04 times 1,200, 0.05 times 800 says the student would have earned $88. So 88 does not equal 92, and so I can say no, I've made a mistake. This is not a solution to this story problem, to this system. So chapter 5, section 1 is to discern if answers work in equations and in systems of equations, and to put a number in for x and to find a value for y in a linear equation.